All right, let's talk about a metal that's probably in your pocket, definitely in your kitchen, and maybe even in your spinach. It's a metal of incredible contradictions, an element that's both absolutely essential for our modern world and at the same time a serious threat to our health. This is the wild story of nickel.
So here's a fun one for you. What's the connection between these three things? I mean, a coin, a high-tech spaceship, and a leafy green vegetable. The answer, of course, is nickel. And figuring out that connection, well, that's when you start to see just how deep this metal is woven into the fabric of our world.
So let's start with its history, which is strange and often really misunderstood. Because honestly, to get a handle on the nickel dilemma we're facing today, you first have to understand where this stuff even came from.
Okay, first, the basics. Nickel, element 28 on the periodic table. It's this tough, silvery white metal. And its real superpower? It's incredibly resistant to corrosion. That one quality makes it a crucial building block for so much of our modern life.
And this timeline just perfectly shows its split personality. You go back to 1751, and German miners are so frustrated with this ore that looks like copper but gives them nothing, they name it Kupfernickel, which basically means Old Nick's copper, as in the devil's copper. They thought a gremlin was tricking them. Then in the 1850s, we were actually using it as a medicine before we really figured out how toxic it could be. By the 1880s, the industrial boom starts. And then, a total flip. In the 1970s, scientists discover it's actually an essential nutrient for many plants. It's a problem and a solution, all in one element.
So let's focus on that useful side for a minute. Because let's be real, without nickel, our world would look and work very, very differently.
The key here is just how versatile it is. Nickel is the magic ingredient that makes stainless steel strong and keeps it from rusting. In industry, it's used as a catalyst, making chemical reactions happen faster and with less waste. It helps form these incredible superalloys that are tough enough for jet engines and spaceships. And, of course, it's inside the rechargeable batteries that power pretty much everything in our lives.
Now, I know this data is from the mid-80s, but the story it tells is still basically true today. And what's so interesting is how we use it. Just look at this. A whopping 42% goes into stainless and alloy steels. Another 36% goes into other non-ferrous alloys. So you're talking about almost 80% of all nickel just going into making other metals stronger and more durable. It's the ultimate support material.
But that industrial boom, yeah, it comes with a steep and often hidden environmental cost. This is where we have to flip the coin and look at the other side of nickel's personality. And it's a much darker picture.
Just to get a sense of the scale here, think about this number. Every single year, we mine over 2 million metric tons of nickel. That is just a staggering amount of metal being pulled out of the earth.
And where does it all go? Well, this chart tells a really powerful story. Natural sources, like volcanoes, they release about 27,000 tons of nickel into the atmosphere each year. But human activities, mining, smelting, burning fossil fuels, we release around 73,000 tons. We are overwhelming the planet's natural nickel cycle by almost 3 times.
And all that stuff we put into the air eventually comes down, leading to widespread contamination. As reports like this one from the U.S. Geological Survey have been pointing out for decades, nickel from our industries settles into our soil and our water. And the crazy part is, once it's there, its estimated residence time can be thousands of years. It doesn't just go away.
And this brings us from the health of the environment to something much more personal, the direct impact of nickel exposure on our own health.
I bet a lot of us have actually experienced this. Nickel is the most common contact allergen in North America, and notice the difference here. Somewhere between 13 and 18% of women are allergic, often triggered by jewelry, compared to just 3 to 6% of men. If you're sensitized, even the tiniest bit of contact can set off a reaction.
But the risk goes way, way beyond a simple skin rash. The International Agency for Research on Cancer, the IARC, has classified nickel compounds as Group 1 carcinogens. To be clear, that's the highest risk category. It means there is sufficient evidence that they can cause cancer in humans. This is a particularly serious risk for workers in places like nickel refineries who breathe in dust containing nickel every day.
So how does a metal actually cause cancer? Well, the mechanism is fascinating and honestly a little terrifying. It's what's called an epigenetic attack. First, these tiny, insoluble nickel particles get inhaled, and our lung cells basically eat them. It's a process called endocytosis. Then, and this is the critical part, those nickel ions can go in and knock out the iron atoms at the core of the enzymes whose whole job is to repair our DNA. With that repair system broken, you can get something called gene silencing. It can effectively switch off the very genes that are designed to suppress tumors, and that can be the start of cancer.
Okay, that's a pretty grim picture. But what if the solution to this big industrial problem wasn't more industry, but something a little greener?
There's this concept called phytoremediation. It's a genuinely brilliant, totally solar-powered technology that uses living plants to literally pull toxic chemicals right out of the soil and water. And when you're using it for metals, you can actually harvest the plants and recover the metal. So they've even started calling it phytomining.
The star players here are these amazing plants called hyperaccumulators. These things are incredible. They've evolved not just to tolerate, but to actively suck up and store huge amounts of metals like nickel. They actually thrive in soils that are so toxic they would kill almost any other plant. The official definition is a plant that can store over 1,000 milligrams of nickel per kilogram of its dry tissue, but some of these species can hold 10 times that amount.
And if you want to see just how powerful these plants are, look at this comparison. This is the real wow moment. On the left, you've got soil near a smelter, contaminated with up to 24,000 milligrams of nickel per kilogram. Basically, a toxic wasteland. But on the right, you've got the leaves of a hyperaccumulator plant that grew in that soil, and it has stored nearly 18,400 milligrams in its own tissues. It is literally mining the poison out of the ground and packing it away in its leaves.
And this leaves us with a final, really provocative thought. We've created this massive industrial pollution problem with metals like nickel. But maybe, just maybe, the most advanced, cost-effective, and elegant solution isn't some new machine, but a field of flowers. Could the future of cleaning our planet actually look a lot more like farming?